This is section 1.4, day 1. Today we're going to talk about how to measure and classify angles. So most of this you're going to be familiar with. We're just going to touch on more the geometry side of it. Like in our first one, how do you name the three angles? In geometry, especially in Unit 1, we spend a lot of time learning about how to name them or how to do notation around them, so we can talk about those geometry terms later on. So first off, in an angle, the corner where the two sides come together, that is called the vertex. These are obviously called the sides, but they're also rays. Like if I just looked at this one from A to C with that arrow there, that's a ray. That's what we've learned. And then A to B is also a ray. So an angle is just made up of two rays that share an endpoint. So how to name them, how to name an angle. You can do it three different ways in this picture. So I can have angle A. We can just say that. A is the vertex, so that can just be the name of my angle. I could also name it using three letters. So I could say C to A to B. So the three letters that make up, kind of like tracing the angle, that could also be the name. So we could go CAB. And we have learned before that if we could do the letters in one direction, we can do them the other way. So the other one could be BAC. The key is that the A, the vertex, has to be the center letter every time you name an angle. And when an angle is by itself, it's pretty simple to do. Angle A, no big deal. But here, when you come into this picture, we can't just say angle X, because I don't know if you mean this little angle right here, do you mean this little angle right here, or are you talking about the big angle? So most of the time, like 90% of the time, you should be using three letters to name your angles. Very rarely do you get away with just using one letter. So to be safe, make sure that you use three letters. This one says name three angles in the picture. So I'm going to start off with angle, and I'm just going to trace the sides. So from W down to X and then out to Y, that could be an angle. I'm going to trace from Y into X and then to Z. That would be the kind of the bottom angle. And keep in mind that these guys can go backwards too. So this could be YXW and this could be ZXY. And then our last one would be the whole one, so W to X and then all the way to Z. And again, that could be backwards. Whoops, W. Could be backwards as well. So those are your three angles. Now we're going to classify them. That means tell what type they are, and these words you have all heard before. So when an angle is small, when it's anywhere from 0 to 90 degrees, that is called an acute angle. When it has a 90-degree angle in the corner, that box in the corner, that is called a right angle. If it's anywhere from 90 to 180, so kind of a big angle, it's called obtuse. And if it's exactly 180, like it literally makes a straight line, it is called a straight angle. But I'm betting you remember most of those. Maybe you flip-flop these. These are the ones that get mixed up the most. So acute is small, less than 90. Obtuse is big. Angle addition postulate works a lot like our segment addition postulate. This is what we were talking about with our P plus P equals whole thing. Works for angles too. If you've got two parts of an angle, like this part and this part, they would add up to equal the whole angle. So same concept here. We're going to use a lot of letters here because we're talking about angles, but we're just going to talk about how to add up those two parts. So if we took angle RSP, if we knew that measure, RSP, and we added it to, that's one of our parts, we're going to add it to our other part right here, PST, so top plus bottom, our other part, then we should equal the whole thing, and the whole angle would be along the outside, so RS to T. So our part whole thing works for segments, also works for angles. And we're going to draw that right on this picture. So it says that given LKN, so I'm going to trace from L to K to N. Okay, so that's the whole thing. I'm on the outside of the angle, so it's the whole thing. I'm going to put a W there. Then they want us to find the smaller angles. So we know that those are parts now because that's all that's left. So a part and a part equals whole. So my first part is 2x plus 10. And my second part is 4x minus 3. And that's going to equal 145. So now we're just going to do our simplify and solve. So I'm going to put my x's together first, my like terms. I'm going to make 6x. I've got 10 minus 3 for 7. And now we just have a little bit of solving for us to do. We have a plus 7 there, so I'm going to go ahead and subtract 7 on both sides. And when I do that on this side, they disappear, and the 6x drops down. And 145 minus 7 is 138. That's multiplying there, so we're going to divide by 6. And 138 divided by 6 is 23. And we've talked before, geometry, you very rarely get to stop at x. You're usually trying to find something, so we got to plug it back in. The first one says LKM, so L to K to M. I'm just tracing those. So we're talking about this one right here. And I got 2x plus 10, except now I know that x is 23, so I'm going to sneak that 23 in there. So 2 times 23, and then we're going to add 10 to that. So our first angle is 56. So the measure of LKM is 56. The second one we have is the measure of angle MKN. So from M, just tracing, to K to N. So they're talking about this one right here. So 4x minus 3. And we know what x is now, so we're going to do 4 times 23 minus 3. 4 times 23 is 92, minus 3 is 89. So there we go. So learning some terms, how to name them, that's huge in geometry, and then doing a little part plus part equals whole.